Okay, let's see the problem for today. It's map indices to parent tree. So a child tree can be made from a parent tree. The indices of the child tree, of course, will be new. Given I, the indices in child tree with length n and r, its root index from parent tree, make a program that returns those indices in the parent tree. So for example, this is the parent tree, right? And if we take the child tree from node 3 here, becomes like this, and the indices will then be mapped to the one with the child tree. So 0, 1, 2 translates to the parent tree to be 3, 7, and 8. And that's why if the input is this child indices, and then 3 is the parent node of the child tree in the parent tree, then the output is 0, 2 translates to 3, 8, right? Okay, then example 2, if we have this kind of parent tree, and the child tree from node 1 is, we take this off, it translates to a new indices. 1 becomes 0, 0, 1, 2, 3, 4, 5, 6, right? And if on the child tree the indices are 0 to 6, 0 to 6, on the parent tree it should be 1, 4, 10, right? And these are the constraints. Okay, so think about it before continuing the video. Pause and try to solve the problem with your thought and effort first. Then only continue the video to see what's the solution of that. All right, let's discuss first on how the indices derive from the parent node, right? So the parent node is 0 here. For the left child, it will always be 2 times parent node plus 1, right? 2 times 0, 0 plus 1 becomes 1. And for the right child, it's 2 times parent node plus 2. So 2 times 0 is 0 plus 2 becomes 2. Same thing for here. For 1, 2 times 1 is 2 plus 1, 3. 2 times 1 is 2 plus 1 plus 2 becomes 4. So it applies on all of the nodes and its children nodes or indices, right? It applies as well for the child tree. That's why when translates to the new indices, so from the node tree here, it becomes 0, 0, 1, 2, right? It follows the pattern on the parent tree as well. So having said that, how to solve this is basically to, if we have something like this, right, 6, we know that if it's 0, it must be the parent node in the parent tree. So if this is 0 and we know that the parent node in the parent tree is 1, so this must be 1, right? And for the other nodes or the other indices, we will try to determine whether it's a left child or a right child. And then we get the parent node of it, right? If it's left child, to get the parent node, we need to minus 1 first. So like this one, 5 minus 1 is 4, and then divided by 2, we get the parent node, right? Divided by 2, it becomes 2. For the right child, 6 minus 2 becomes 4, divide by 2 becomes 2. So that's how we will get the parent node and traverse it the whole, go to the whole up until it reaches the zero node in the child tree, and we translate back that to the parent indices, right? So let's see the working solution for it, the code. So we we use the recursive approach here. Say the function name is map index to parent tree. For the base case, whenever the indices has no elements, we just return empty array. While it has elements in it, okay, if that element, right, we first take the first element of it and try to map this first element on the parent tree. Okay, if it is 0, as I explained it before, it must be the root index in the parent tree, right? If it's not 0, that means we need to get the parent node of it first in the parent tree, and then we times 2 and then plus 2 for the right child, or plus 1 for the left child. And that's what this part of code doing here. So in order to get to know whether it's a left child or right child, we simply uh, do the modulo uh, operation here. If the remainder is 0, it must be the right child. That's why we 2 times this one is the parent node for that node, right? And then plus 2. Now the indices now has been mapped to the parent tree instead of the child tree with this recursive calls. And then for the for the left child, 2 times the parent node plus 1. Now why it takes the first element here? Because on return statement we return 2 things, which is the first one, the mapped index for the first element that we take out, right? And the rest of the indices, we will go to the recursive calls again to the function and pass the remaining indices inside it. Okay, so that's why here we get only the first one, and we only call also to get the parent node of the current one we are evaluating by passing only one element of that node, right? Because we only want to get what is the parent node of this current node that we are looking at. So that's why we do not need to pass anything else. We just need to calculate this up to the root node, and then it goes back again, but right now in the parent tree index instead of the child tree index. All right, hope it's clear. If you have more efficient code or the other way of approaching this problem that might be better in some way, or just another way how to solve this problem, just let me know on the comments so that the audience or the viewers also can make a comparison between the solution. All right, thank you, and see you on the next problem.